believe many people have experienced the pain of a gutter ball. You may ask, is there any method to prevent this from happening? Thankfully, we have learned the Six Sigma. In order to get higher score, we will apply the knowledge we learned from the Six Sigma course, the DAMIC approach, which includes define, measure, analyze, improve, and control. In the define phase, we mainly use project charter to illustrate the overview and the objective of our project. The main objective of our project is to assist bowlers, especially beginners, to knock down more pins and score higher points. We started our project by searching related information and then further defining the problem and making different tests on the factors. After reviewing them, we proceed to finalize the vital factors and write up a report before drawing conclusions. In the measured phase, we carried out investigations to ensure that our measurement system variations are within the acceptable range. Before proceeding to gauge R&R analysis, let's have a quick look at the quality function deployment. In our QFD, we look at the factors that would affect the outcome of the bowling score. In general, we would focus on the force, velocity, accuracy, and spin of the ball. In respect to that, we identified three key factors that are crucial. In achieving high bowling score, we will need to focus on the ball to body mass ratio, lane chosen, and the angle of incidence. The red arrows in the diagram show the lower and upper limit, which were set to determine the boundaries. This process was carried out for all three positions, each measured 10 times by two operators. This distance represents where our bowlers step on during our experiment. The purpose of the total gauge R&R is to ensure that we can repeat and reproduce our measurements used in our DOE later, thus making the data reliable. The total gauge R&R is just under 16% for the percentage contribution, which is acceptable. As for the percentage tolerance, the total gauge R&R is just under 30%, which is also acceptable. The part-to-part variation is expected, but there is some interaction in part 3, as you can see the steep drop in the curve of the last graph. In the analyze phase, we use the cause and effect diagram to see what factors will affect the bowling scores. Firstly, we categorize the factors into 6 groups, namely people, method, measurement, machine, materials, and environment. We also further explore other factors for each category. After that, 3 bowlers will carry out experiments for 10 rounds to identify which are the vital few factors that favor higher bowling points. Of all the factors, the 3 most significant ones are the ball weight, angle of approach, and the label mark's position. However, we found that the strength of a human might affect the handling of the ball. So, we repeat the measurements by using ball to human body mass ratio, and the results are discussed in the improve phase. In the improve phase, design of experiments were carried out to see if all factors and interactions of factors are significant to affect the response. As mentioned, the 3 main factors that will increase the number of knockdown bowling pins are ball to body mass ratio, lane chosen, and angle of incidence. Our first round of DOE concluded that there are 2 interactions of factors have p-value greater than 5%. Therefore, we eliminated these 2 factors, rerun DOE, and obtained the following Pareto chart. Among these factors, it is shown that the lane choice is the most crucial factor, as the standardized effect is almost twice as much as the others. The main effect plot substantiates the Pareto chart that lane chosen is the most significant factor. It is shown that the optimal number of knockdown pins can be obtained by using lane 2, together with a ball to body mass ratio of 0.06 and a 0 angle of incidence. As for the interaction plot, the results are also consistent. The non-parallelism indicates interactions, and Pareto chart tells us that the interactions are statistically significant. Fitted with a straight line, the residual is normally distributed with a mean of 0 and a constant variance, such that the versus fits plot has a random pattern and the versus order plot has most of the points within the limits. This shows a strong agreement with previous findings where optimizing the 3 significant factors will result in a better score in bowling. Therefore, we can make use of the mini-tab to determine the factor of our goal, which is to get a minimum of 9 bottle pins down. By maintaining a ball to body mass ratio of 0.06 and 0 degree of angle of incidence on lane 2, the results shown that the desirability of getting 9 pins is as high as 87%. You may wonder, how do the professional players get higher score than this? One thing to keep in mind is practice makes perfect. By keeping the requirements unchanged, all of these figures would definitely increase with more trainings. The last part of the DEMAIC approach is the control phase. In this case, we use the statistical process control to monitor the effectiveness of the aforementioned methods. After improvement phase, it is important to monitor the measures implemented on X to ensure that they are effective on the output Y. First, we identify which control chart is suitable for our project. Our output, which is the bowling score, is discrete. We consider each run is defective if the knockdown pins are fewer than 3. Thus, we will be using the proportion mode. Our subgroup size, which is the number of runs for each sample, is kept constant at 10. According to the control chart selection flow chart, NP chart will be used for our project. In the control chart data table, it contains 30 samples. For each sample, we take 10 test runs and count the number of runs that have fewer than 3 knockdown pins. The above formula are used to calculate the upper and lower control limits as well as the mean. Minitab is then used to generate the NP control chart. As we can see, all data are well within the upper and lower control limits. Therefore, we can conclude that outputs are in control and that our improvements measures are effective. After following the DMAIC approach, what could we expect? Let's find out.